We have our next speaker, Ankush Verma, who is from Multimedia Architecture Engineering team at TikTok. And Ankush will delve into Trantor, TikTok's powerful transcoding strategy platform, and how we optimize video delivery on our TikTok platform. So thank you, Ankush.
Thank you, Winnie, first of all, for introducing, and thank you, Jamie, for making my job easier. Hi, everyone. My name is Ankush. I will be covering upon the TikTok Trantor system, which covers the whole encoding within TikTok. So, just a brief background about me. I joined Multimedia team 4 years back, and I have been continuously working on multimedia. I've learned a lot in this domain, and I wish I can share whatever I've learned in the session. But since the time is limited, let me quickly jump on to the agenda. Okay. Yeah. So, as Jamie mentioned, right, there is H264, H265. You can also call it byte VC0, byte VC1, byte VC2. These are all video technologies these are called like codecs. Before I delve more into it, I want to just quickly summarize the audience in case you are not familiar with it. It's the codec which helps, which you can compress better and you can retain the same quality. So just to quickly explain, H265 has bunch of benefits over H264. One of them is you can get a smaller file size and retaining the video quality. That basically means you use less bandwidth over the internet. So today, over the internet, the most of the bandwidth is used by videos, and TikTok has a bunch of videos. I don't need to explain that part. And there are other advantages which I will be covering in the later slides, and maybe I can just say that with the advancement of technologies, we can actually compress the video better, and with the better decoding technologies, we can decode it better with the high computation powers we have with GPUs, CPUs, and etc. Moving on, scale at TikTok. So today, TikTok supports a bunch of videos which are uploaded daily to the platform. With the video uploads, our platform supports 3 billion messages. These messages consist of video which are uploaded to TikTok and also the video views that happen on every video. This system processes every message. Now you might be wondering, with this 3 billion messages per day, how do we even process such a huge amount of chunk? With this 3 billion messages, this serves as our most powerful thing to generate 200 million different kind of encoding per day that we transcode in TikTok. This later on helps us to also provide data to the model training, which is very essential to keep on iterating. And we also do various, we continuously also iterate over the experiment around video so that video quality we keep on improving. So moving on to the next part. I will not touch upon the system yet, but briefly explaining the golden circle. The golden circle says within an organization, everybody knows what we do. Among that subset, there are people who knows how we do it, and there is always a small segment why we do it. In this presentation, my only purpose is to explain why we do all this. So let me quickly explain the what part, right? We basically, at TikTok, ensures that we are able to transcode every video. Also, our purpose is we can generate this all videos with a high quality content. This is what we do. Moving on, why we do this? I touched upon previously in my slides that byte VC1 is very powerful than byte VC0. Then you guys might be wondering, why do we even need byte VC0 if byte VC1 can serve all the purposes? The truth is, every video cannot be processed by every device because the complexity behind decoding byte VC1 is complex, and Personally, I have been using iPhone 6 for some time, and it is not easy to decode high complex encoded video on a low-end devices, which is getting outdated. So at TikTok, we want to ensure everyone can watch every video if they really want to, no matter which device they are using, where they're sitting in the world. So that's why ByteVC 0 serves as a foundation to provide a universal access across TikTok. The other thing I mentioned, I talked about iPhone 6. I can also talk about iPhone 16. I bought an iPhone 16 in US with a high bandwidth. I would never want to watch a 360 pixel on my high-end device because I paid money to buy a high-end device. So my purpose is, can I watch high-quality content? Because I have all the device, I also have all the internet. At TikTok, we want to ensure you can watch high-quality content if you can support it. That's why this system, within TikTok, Trantor, ensures we generate both quality content so that everybody can watch it. Moving on, how we do it. I skipped how the part in the between what and why. How we do it is using this system. So this system serves as a core of processing every message that comes to TikTok. It includes videos which are posted. It also includes the videos which are viewed. So let me quickly go over this system so that I can give you a small idea about how we process those messages. As soon as the videos are uploaded to TikTok, I will not talk about the video views, I will talk about the video post. As soon as the video is coming to TikTok, it hits the gateway service. Gateway service acts as a barrier to not make the message go down to the downstream services, because we want to ensure where the video is uploaded is processed in the right data center. A US video will be processed in the US data center. Gateway service ensures that videos are basically moved to the right DC if they are not processed. It also acts as a central piece to unify the messages, because the messages can be of different types. It unifies the messages and passes on to the next system or next service, which is the pre-process. One of the key principles of the whole system is to reduce the sample size. Why do we need to reduce the sample size? Because there are 3 billion messages. If I give 3 billion messages to the algorithm team, which my colleague will be touching next in the next presentation, they will say we cannot rank 3 billion messages on the fly. So we need to ensure we provide the right sample size to the algorithm team so that they can actually make the right decision on the right sample size. So after the gateway, the messages goes to the pre-process. In the pre-process, we figure out this video, what are the right templates which needs to be generated. There are some base ladders, like as Jimmy mentioned in the slides. There are like base, watermark, transcoding we need to do for the encryption purposes. We also need to do higher encodings, let's say 1080. How do we do that? Pre-process figures out this video, what are the most likely templates that we should generate for this video. Just in mind, these are just eligible ones. These are not actually getting transcoded. After the eligibility, we figure out of all the sets, what is already transcoded, because we don't want to waste our computation power if they were processed by some other instances or somewhere else. So this ensures that. Next, we move on to what we call it internally as a preferred good, but you can also consider it like different kind of priority queue, where we sort each messages into different criteria. For example, a video with 10 million fan following will be sitting high in the fans queue, but that video might be just uploaded. It might be below, in the bottom of the queue in the video views. So these are the sorting criteria. We have fans, VV, create time. After we sort them, we basically regularly keep on picking these items so that we can process them. This is the job done by the decision service. Decision service acts like or we call it strategy service, sorry for that, but it acts like a heart of the whole system. It talks to the model, where I will not be touching on the model, but it's the video value model which Shanglan will be touching in the next presentation. We get the decision making to the model. That model tells us what is the video value. Is it worth transcoding or not? We also need to consider what is the computation power available to us at this moment. Maybe the model says, let's transcode 100 videos, but the computation power is available is only 50. We need to make that decision on the fly and only transcode the high valuable videos. We make the decision listening to the feedback of what is the computational power, what is model predicting. Also, there can be decisions like, this is an ads video. No matter what, we want to transcode it. I don't really care if I have resources. I need to queue them up so that they can be processed. So all that computation decisions are made by strategy service. After that, the decision is made. We basically send the message to scheduler to find the right machine which is available, which kind of computation it needs to use, GPUs, CPUs, higher encodings, whatever needs to be done. It figure out the right machine and give it to the downstream services, which basically process it. And after that, these videos are ready to be viewed. One of the key purpose, let's say we don't do this encoding. How can we watch the video? We can still watch the video. We have to watch the original video, which is very costly. In terms of the file size, we will eat up the whole bandwidth. So this encoding is very critical for the whole system. So as Jamie mentioned, we are moving on to the video content. We are using CAE decision making on can we make our decision better. So this is what our next steps are. We want to make the right decision based on the computation power we have. Can we also include the video content? Because right now the video value might not be covering everything. So this is what we are doing next, where we want to consider the video content along with the video quality to make the decision. Another thing we are doing, I mentioned, model told us we can transcode 100 videos. We have only capacity for 50. We have a scale of 3 billion, and this scale will continuously increase with the TikTok growing demand. Can we process more messages? Can we process them more frequently? Current systems, like the previous system, was developed keeping videos in mind. We have evolved from videos to images to videos with e-commerce videos, bunch of stuff. We have also entered into the subtitle generation. All that is only possible if we can make it like a platform. And the new system currently supports sorting up to 10 million items on the fly. So at any moment, we can find the best videos among the 10 million videos. Previously, our selection size was limited to 1 million. So we are expanding continuously to support the growing demand. That's what we do. And moving on to the next part is the experimentation. I'm not touching much on the experimentation part because I think Jamie already covered, but I will just play a video. This is an example of 2 experiments which were carried out within our team, and you might see how different the quality can be generated, which can act like the main whether a encoding should be released or not. So I will just play the video. I'm not sure how clear the video was from the background, but from here I can definitely tell one video was definitely way superior than the other one. These are both experiments carried out, and as Jamie mentioned in the previous slides, we use the metrics, all the video metrics, to evaluate which one is performing better. And I don't really need to mention the video on the left was the actual one which was released. Okay, thank you.